Hello, everyone, and welcome to another episode of Tools on Tuesday, where we chat about the weird, the wacky, the lesser known tools of science. I'm your host, Jacqueline from Telespark Science Center, and I hope you're staying nice and toasty and warm because today we are exploring tools for combustion chemical reactions. Before we begin, I would like to ground us to the land. The Calgary Science Centre, operating as Telespark, is a registered educational charity in Calgary, Canada. Spark thrives on the ancestral lands of the Niitsitapi Blackfoot Confederacy and is grateful to these long-standing caretakers of the land who, alongside the Tsuut'ina, Eyahi Nakota, and the Government of Canada, signed Treaty 7 in 1877. It acknowledges that Treaty 7 sets out an agreement for reciprocal peace and friendship between self-determined peoples. The city of Calgary is also home to Métis Nation Region 3. As a first-generation Canadian in my family, I have much gratitude for this land. Thank you so much for joining me from wherever you are across Canada and the globe. Have you ever wondered why fireworks burn different colors, what the sun is actually made out of, or why you should never set your farts on fire? In today's episode, we are exploring combustion chemical reactions. Let's break this down a little bit. What exactly is a chemical reaction? Well, essentially, it's when you mix a bunch of products together, something happens, a transformation happened, and the change typically can't be undone. But let's conceptualize it in a way that you and I understand. Imagine baking a cake. You have all of your ingredients together. You're mixing in your flour, your sugar. You've got your chocolate in here. Nothing is really happening. This is just a physical change. But as soon as you pop this into the oven, ding, something happens. A transformation happens and the change can't be undone. This is a chemical reaction. You can't take out the eggs again. You can't separate the flour and the sugar. Everything has transformed, a chemical reaction. There are many different types of chemical reaction, but today we are exploring combustion chemical reactions, or in other words, fire. Now, I have the perfect recipe for a fire. It's something called the fire triangle, which means that there are 3 ingredients that you need in order to start a fire. It's a fuel source, a heat source, and the most important ingredient, it's oxygen. I have something special to show you here today. We are going to be making many different types of flames, some even colorful flames. And this is what I'm going to use to show you some colorful flames. It's strontium chloride and copper chloride. These are metal salts. And one thing that I'd like you to know is that different metals burn different colors. If you ever wondered why fireworks burn blue or purple or pink or yellow, metal salts. Let me show you that here today. Inside of these containers, I have mixed in those metal salts with an alcohol, ethyl alcohol, and I'd like to show you why fireworks burn different colors. Now I'm just going to grab my lighter here. Remember the fire triangle. We need a heat source, a fuel source, and most importantly, oxygen. So let's complete the fire triangle here today. Let's add our heat source. Bam! We're going to have our fuel source right over here, our strontium and our copper chloride, and finally oxygen, which is everywhere around us. Now, I want you to guess, what color do you think strontium, a metal, will burn? It looks like clear liquid here, kind of looks like water. Put in your guesses down below or think about them to yourselves. Strontium. Here we go. Ready? In 3, 2, 1. Ha-ha! Strontium burns a beautiful, vibrant red. Now let's test copper, another metal. We mix in the metal salts, remember? What color do you think copper will burn? Here we go. In 3, 2, 1. Ooh, very beautiful. We're getting a nice bluish green here. So now you know when you watch fireworks, if you see a bluish green color, you know that they put copper in there. If you see a nice magenta reddish color, you know that they put strontium. Let's just have a little bit of fun and mix the 2 together. Staying nice and toasty. There we go. Very, very flammable substances. I should also note, please don't try any of these experiments at home, especially the next one, because we are going to show you a very flammable substance that you can probably find in your kitchen. Remember, don't try this at home. We're going to show you another fire triangle experiment. Inside this container is a very flammable substance. It's a powdery substance here that you can use in your baking, and it's none other than flour. That's right, my friends. Flour is a very, very good fuel source, which means it is very, very flammable. Let's not try this at home. I'm going to show you here today, as trained professionals, just how flammable flour really is. But keep in mind the fire triangle. Remember, fuel source, a heat source, and oxygen. Let's see what we can do with flour. Adding our heat source. We've got our fuel source right over here and oxygen all around us. Let's see what happens. Ready? In 3, 2, 1. Well, we don't really see much happening here. Maybe a little splurts here and there, which means we can crank this up a notch here. Let's think about this for a second. Fire triangle. We need a heat source, fuel source, and oxygen, but something is missing in this experiment. We need to add more of it. Well, we've got our flour here, which is our fuel source. We've got our heat source right over here, but oxygen is the key ingredient. Now, if you remember, flour, it looks like little teeny tiny particles completely densed and packed together, which means that it doesn't leave a lot of room for oxygen to float around. So, Spark has given me this wonderful garden hose because we don't need it here in Calgary at the moment. We're going to put in a little bit of flour here. What I'm going to do is I'm going to blow oxygen into this experiment and see how big we can get this experiment to go. Now, this might sound familiar when you're at a campfire or something. You might have seen people blow or use newspaper to flash some oxygen into the fire. That's all because of the fire triangle. You need oxygen to make it grow bigger and bigger and bigger. So let's do that here today. Here we go, completing the fire triangle. We're adding our heat source. We've got our oxygen. And finally, last ingredient, a fuel source, our flour. Here we go. In 3, 2, 1. There we go. Please don't try that at home. This is something that we call dragon's breath. That was really, really cool. And we saw a lot of neato experiments here today, but it happens really fast. Combustion chemical reactions are really rapid. So I'm going to show you again our copper chloride just once more. You're going to see this beautiful flame here. I've soaked in cotton balls with the copper chloride. And what you're seeing is the copper burning, beautiful blues and greens. Now, if we remove something from the fire triangle, you're not going to get a fire. So let's see what happens when I smother the fire or remove the oxygen. Ready? Here we go. Oh, it's still there. Got to do it a little bit longer here to get all the oxygen out. And in 3, 2, 1, it's gone. Once you remove something from the fire triangle, you're not going to get it again. That can be really, really dangerous. But you know what else is dangerous and deadly? Your farts. Here's the reason why you should not light your farts on fire. It has something to do with a gas that you produce, methane. Now, that's not the gas that makes your fart smell so funky. That has something to do with sulfur. Methane gas is actually an odorless gas found everywhere in our atmosphere. And it doesn't smell like anything. People actually put different gases into this tank so that we can smell it in the air because it is highly flammable. Now you produce this gas, which means technically, now don't try this at home, but technically your farts do light on fire. Instead of testing it on yourself, we thought that we would do it here for you today. So methane is in this tank. We're going to be creating a nice fart bubble monster. Here we go. You produce this gas, cows produce this gas, and you know what? Teeny tiny termites produce methane gas the most. So we're gonna get a nice bubble bath here today. That looks good to me. Let's get our stick of science. And let's light some farts on fire. Here we go, my friends. Ready in 3, 2, 1. Woohoo! Please don't light your farts on fire. You might be a risk taker, but we're going to be doing some risks here today, and I brought along my friend Mel. Mel is joining me here today, and she's going to be helping me demonstrate another experiment. Welcome, Mel.
Hello, hello.
Hello. How are you today?
Not too bad.
Thank you for joining us.
Thank you for having me.
Are you up for this experiment here?
You know, I'm not ordinarily up to, light my limbs on fire, but I'm ready to go.
You're ready. That's right. She's going to be lighting her hand on fire. And this is going to demonstrate something really important, but please don't try this at home. Now, on the bottom of the table there, you're going to see a bucket of some sort of liquid. It's a very special chemical. Can you bring it up? This chemical, my friends at home, is going to protect Mel. And Mel, just using your observational skills, what can you tell us about this liquid?
Well, it is very clear. Could be a few things, but I'm gonna go with water.
Water, that's right. Water is a very, very, very special chemical, and we need this in order for us to survive. In fact, your bodies are about 70% just water. This is going to help Mel protect her hand because we're going to light her hand on fire. So Mel, why don't you grab the methane tank over there? Let's create another fire bubble, a fart bubble.
Excellent.
There we go. Fabulous. All right, and you're going to dip your hand into that nice liquid there.
All right.
Yep. Grab yourself a nice scoop of fart bubbles.
Never thought I'd do that.
And whenever you're ready, let's light your hand on fire.
Okay.
Woo!
Wow.
How do you feel?
That's cool. It's warm, but safe.
And you know, your skin is intact, your hair's there, nothing is wrong.
We're all good.
That's fantastic. That's all thanks to H2O. Water has a really, really high heat capacity, which had the ability to support Mel during this experiment. And this is also why it takes a really long time. I don't know if Mel, have you ever waited for your pasta to boil?
Too often.
Yeah, it takes a really long time. Water absorbs all of that energy before the temperature can rise and hit your hand, and also why it takes so long for us to boil pasta. Now, Mel, that was a lot of fun, but we have another experiment for our visitors at home here.
Sure.
And it's something called fire roulette. Have you ever played this before?
I'm not much of a gambler, but I'm willing to try.
You know what? Gases, we've explored paper, that's really flammable. We've explored flammable liquids, but we haven't explored flammable gases yet. Now, different gases can be flammable. And there are different types of gases found even on our sun that are really flammable. It's something called hydrogen gas. Hydrogen is very, very flammable. And we've got some balloons over here for you today. So Mel, why don't you go over there to the balloons? We're going to demonstrate this here. There we go. And friends at home, this is a game that you can play as well. Inside one of these balloons is hydrogen gas and helium gas. They float. It looks like helium gas or the gas that you put in your birthday balloons. But there is a hydrogen gas balloon somewhere in there. If you can guess which balloon has hydrogen gas, everyone watching right now, you're going to go home with a very special discount code to the Spark store. And you can buy anything for your sweetheart for Valentine's Day, but you have to help Mel find the correct balloon. Are you ready? All right, Mel, let's let the audience pick which balloon. Can you show them which balloon is which?
This is balloon number 1, balloon number 2, and balloon number 4. Just kidding, balloon number 3.
Balloon number 3, 1, 2, and 3. Which one would you like Mel to blow up? All right, Mel, it looks like balloon number 2 is the winner. Woohoo! Was that hydrogen or helium, Mel?
That was helium.
You're right, that was helium. Helium is the birthday balloon that we use in our birthday balloons because it is a noble gas and it does not react with anything. but we do have hydrogen gas, a very combustible, flammable gas. So Mel, let's go and blow up balloon number 2. Friends at home, this might be very loud, so turn down your volumes if you want. Here we go in 3.
That was balloon number 2.
Oh, sorry, balloon number 1.
All right.
Here we go. In 3, 2, 1. Woohoo! Wow. Hydrogen gas. That's why we don't use hydrogen gas in our birthday balloons. Thank you, Tiger Shark McGee, for that recommendation. We're going to do balloon number 3 last. Here we go. Yep, just for fun. Amazing. Thank you so much for your help, Mel.
Thanks. Anytime.
So we learned a lot about fire here today. We learned that different liquids and solids and gases can be really flammable, especially flour inside of your kitchen. So it's very important to be safe with that. We also learned that the sun has hydrogen gas and helium gas on it. And we learned that hydrogen gas is a very flammable gas that should not be used in our birthday balloons. We also learned why fireworks burn different colors because of metals, and why you should not light your farts on fire. Now, my friends, we are nearing the end of the show, and it wouldn't be a fire show, if we didn't show a little montage. So for those of you at home, I hope you're staying nice and toasty. Mel's got this all set up for us here. We're gonna do a little experiment montage for you to end the show. Thank you so much for joining us. If you want to check out Tools on Tuesdays next week, we're chatting with a vet all about the brains of kangaroos and dogs and cats. We're looking into MRIs. Here we go, Mel, you ready?
Yeah.
Thank you for joining us.